Okay, we're back. Well, let's finish lecture number 1. In fact, we're going to catch up with the PowerPoint to what I showed you in Xcode. Believe it or not, we're going to be building projects very soon, which will be more interesting than some of the fundamentals. But we have to get through the fundamentals to work forward. All right, so we talked about, I showed you already, the instance variables. Those are the integer age, integer height, name. So new objects contain not only instance variables, but they're also defined within the class, and then instance variables that are defined for the superclass also root back to every class in the hierarchy. So subclasses get the instance variables of the superclasses, and everything all the way down the roads, which is the same thing that happens in other programming languages as well. And then we have the concept of the methods. The methods are those functions that we saw. And so the object can access not only its methods, but the ones in the superclasses as well. Same thing with the variables. And then we have method overloading, which is where we're implementing a new method with the same name as one of the predefined methods or predefined classes in the hierarchy. And the new method overrides the original. Instances of the new method will be performed rather than the original method. So when you override a new method in a class that's inherited from another class, then we get everything plus whatever we change, we get the new version of it. So we can reference the object as its superclass or as its subclass, and then we can get whatever version of those methods that we want. Same thing that you get with Java. You have information hiding, you have overloading and overriding of functionality as well. Works the same. So our class object that we just looked at in Xcode actually was the person or the student, which is the object. So a compiler creates one class object to contain the information of the name of its superclass. In here, to start an object in a class, we have the ID rectangle as an example, and then rectangle is going to be equal to rectangle alloc and then init. We just saw that a few minutes ago live with person and student. The alloc method returns the new instance, and that is an instance that performs an init method to set its initialized state. So init is short for initialization. They call them initializers in the language. So when you define a class, you're defining the .h interface and the .m implementation. So we covered that part as well in terms of the file format. The interface, just to give you the textbook definition of it, is that at interface and at end, everything goes in between. And it kind of looks like this. Declaration begins with this thing, they call it a compiler directive. That's what this at symbol is all about. So at interface class name, colon, its superclass. In our case, NS object for the most part. So then we have our instance variables and our declarations. So in terms of our declarations, we have built-in primitive types, and we also have object types. Object types, anything that's an object takes an asterisk. It's a pointer. Anything that's primitive doesn't need an asterisk. So we can still do integer I, and here's a couple of them here, float W, and float width, and float height. But here we have an object, and the object starts out with NS, our next step. So I'm going to give you a little history. I'll probably wait till tomorrow for the history, because if I give you too much textbook stuff in one day, you guys get bored. So a little history tomorrow. So what do we got here? NS color, the asterisk. And remember, you can put the asterisk before the name of the reference, or you can put it along with the data type. Doesn't matter where you put it. And then we have the methods. And as I mentioned before, we have methods that are instance methods and methods that are class methods. So here we have methods, and here's the name of a method that can be used by a class object. And so we have class methods that are preceded by a plus symbol or plus sign. That's our plus. So that's actually plus alloc is actually a class level. Alloc is a class level method, by the way. It's a class level that we run on any object to create an object. And it is an instance. It's an instance method, actually. You don't need to know that. You run them the same way. We've been running alloc all the time, actually. Did alloc look any different than init? Nah, he's the same way. So to answer somebody's question earlier, I just can't really tell whether it's an instance or a class. It just depends on where it's defined and what it's used for and how it's being used with the objects. We're definitely going to repeat, or not going to repeat, we're going to get into this concept later, probably in the second weekend. This weekend we're talking about methods and instances this weekend. We'll talk about class methods next time, but we have 3 weekends of this, so we'll definitely catch that before the end of the course. Also here we have an example of the minus sign here for the instance method versus the class method. Just remember it is a symbol. You could put a space. I don't like to put spaces in. I have a tendency to leave spaces out, but you could put a space in. It is all the spaces are ignored actually, so it doesn't really matter. Wow, someone's got heavy foot. You got heavy foot. I'm like, I could hear you coming. So,
I was running.
Oh, all right. So yeah, let's go back to the import concept. We import the interface into the implementation. So the interface is usually included in the at directive here. We got import. So we have, the hash sign, a number sign, import directive. So import rectangle.h. We can also include rectangle.h as well, as you saw earlier. So to reflect the fact that the class definition builds on the definitions of the inherited classes, we refer to the other classes inside of the classes. We can say at class rectangle, comma, circle. We can include classes inside of classes to actually build on them. So this refers to other classes. If the interface mentions classes not in the hierarchy, it must declare them with an at class directive to declare them. So going back to that comment made earlier about multiple line inheritance, it's not technically not inheritance, but you can include functionality from other classes that are outside of the inheritance. So although you can inherit one class from another class from another class, well, you can also use the at class directive and bring in even more classes if you want. You're going to refer to something that's in another class in another hierarchy. Then you can. Why not? Bring it in. You do have to, this is, I would say, it's used in limited cases because, for the most part, you're going to stay within the same hierarchy for functionality purposes. When you start bringing in other functionality, then it's a matter of, well, I wonder what that's used for, or why, kind of thing. So sometimes it doesn't make any sense. So the implementation, here's an example of the implementation file. I just showed you a couple already, actually. So we can kind of, you've seen the source code, so we're going to kind of skip through that. In terms of an example, here's an interface worker that's coming from the NS object. We have character, name, and we have a integer age and character evaluation. And then before I said, well, all the objects have to have pointers to them, but you can have pointers to non-objects as well. Character is not an object, but I have a character array, a character pointer name instead of using strings. So the same stuff that we did in C++, this is very C++-like. We have the at private, at protected, at public. You're not going to necessarily see that, but in C++ you would see private colon, and then a bunch of stuff that was private. And then you have your defaults. Your defaults are pretty much the same. Data members are always private, member functions are always public, but you can switch them around. You can make the access methods anything you want, actually. If you do that, instead of going private colon, you're doing at private. You're telling, basically using the at directive, you're telling the compiler, hey, these are public, these are private, and this is how you're going to treat it. And this is the interface, and in the interface we have make identical twin, promote to new position. Now here's an implementation of promote to new position. I didn't see promote to new position in our interface though, which is kind of interesting. But long story short, here's an implementation of a method. We actually saw this live, so it doesn't really matter. I'll just kind of skip through. We saw this live as well. We can use a GCC compiler and your GNU step compiler. Go GCC or CLang or whatever we want, a command line. And here's your GNU step, so written completely. This is the Linux Unix version of it. You can actually use, so some of you who are downloading Ubuntu, this is what you're downloading, actually. Add that to your Ubuntu kernel. Go to a C prompt, or excuse me, go to a terminal prompt and C shell or bash shell. And you can type in GCC after you have this package installed inside your, and then you can use what I'm doing on my MacBook essentially. You're not going to get any GUI out of it, but you're going to be able to have a command line compiler that you can use. I believe there is a version of Xcode that's been modified that works. You can also download and use as well. If you use that version, you also have to have GNU Step installed. So most likely at the same website where you can download this, or at the same repository, if you're using an apt-get or something like that on your Ubuntu system, you can probably find the Xcode version. It's probably not going to be called Xcode. It's going to be called something else. So. Actually, you can try this. It's in slide number 23 from your Ubuntu GNU Step. So it's a Coca clone. It's not a full version of Coca. It's the clone. It's the free clone. So if you go sudo apt-get and then install the build essentials, and then the other tools for the make and for the base development system, or on a Windows system, you can go to gnustep.org. You might actually, I've had some students do this on your Windows system. You could possibly install GNU Step with a CGWin on your Windows system. It takes you to a Unix prompt. Windows prompt. CGWin is like a Windows interface to Unix. Well, the Unix shell that pops up. Not a full-blown version of Unix. It's kind of a stripped-down version. A few years back, there was a guy who packaged it all together. You just downloaded it, installed it. You had GNU Step, GCC compiler on there. And it was originally designed for Windows people who wanted to write C programs with threads, which is not supported on Windows either. So, and I know people have been trying to get around the Windows issues for years. Why all you guys have Windows computers is beyond me. But I don't know why people use Windows, really. So, anyway, but I'm not going to rant and rave over Windows or complain about Windows all weekend. Although it seems to be sounding like that. So anyway, file overview. The source code file's got the .ems on them and the .h files. We saw that before. But you need to add Coca or GNU Step frameworks to the build. So if you're going to use GNU Step, instead of using the framework foundation, you're going to use a different framework. So go ahead and save and make sure it comes with some sort of documentation, or you'll have to go online and figure out which libraries you're supposed to work with, what frameworks, because there's going to be a separate include file and a separate framework that you're going to work with. Doesn't really matter what it is, it'll work on my system. I just changed the foundation and it works on my system, no problem, hopefully. And we looked at this already. Here's a little example of a foundation, foundation.h. Here's a main program with this auto-releasable. Notice I took this out and it works just fine. Newer version doesn't need it anymore. Automatic. Which is kind of like what my suspicion was to begin with, because I'm like, why do you have to turn it on and turn it off and make it automatic? Just make it automatic all the time. Why do people want to play with memory? Maybe some of the older projects might have a problem, but I did notice there's some backward compatibility options. So we're going to see that when I start loading up some of the older projects. So compiling. To compile, you've got the hello world in the Xcode. If you're going to do it in Xcode, we actually just saw it compile. We built and ran it a couple of times, actually, so we looked at that already. We also did this. We did before lunch, actually, the GCC Framework Foundation. Hello M, we did that already. We ran it from a command prompt. So if you missed that, you can watch the video, actually. And in the hello world that we saw the NS string. So the constant NS string, which is preceded by this @ directive. For example, @hello world. You'll just get used to it after a while, and the you will actually put the @ in front of everything. By the end of your tour through Objective-C, and then you'll go, why am I putting that out there? Take that out of there for C++ or for Java, for other languages. So you notice that NSLog also outputs the time and date and various other information as well. We saw that actually. We don't have to create a pool. We don't have to release a pool or drain a pool. So I'm not going to cover this because we're not going to have to do it in this class actually. Because this class we're working with a brand new version of Xcode that doesn't require it. So. Which brings up another interesting point. If you're going to use the GNU Step, I seriously doubt you're going to have, if you're using this technique here, I seriously doubt you're going to have the latest and greatest. Which means, you know, the one I got downloaded today was for iOS 7, which means I don't have to worry about memory and all that other stuff. I still have to alloc and init but I don't have to do the auto release pool or anything. You may end up having to do it because you're not going to have the advantages of all the automation that we get now, the newer version of Xcode. You'll be working on an older version. I seriously doubt they have rewritten it to work with the modern day. Just was released this week. Actually, it may have just been released today, actually. New iOS 7? I seriously doubt the GNU stuff is that up to date. Which means you may actually end up having to go back to Lecture 1 and taking a look at this, how to create the NS auto release pool and how to use memory pools to load all your stuff in. So if that is not another reason why to go out and buy a MacBook, I don't know what else would be. So it's harder for you. If you don't have a MacBook and you struggle to do it the hard way, and you finally end up, after 8 or 10 hours of setting up GNU Step and getting it all working, you're going to have to go back to version 4 or 3 of Objective-C, earlier versions, because that's what's going to be supported. And you have to no automatic anything. You have to manually configure your auto release pool and drain your pool and release. Do your own memory management without any automatic garbage collection or anything for you, which is what you get in the current version. Because you can't run the current version, it's not going to be supported. All right, there's my reason alone. That's why I would just go get a MacBook, actually. So, it'd make my life easier as a programmer. See, some things to note about NSLog. No line breaks are needed at the end. You gotta get one automatically. And string constants use a C style variable. And you can test the program and see results, actually. So, all right, so we already looked at another similar program. Actually, we looked at students. And we looked at person, I believe. So, and here's remember student with an M undergrads and postgrads, and the print and the set and get. We just looked at that example. What I did is I kind of showed you live the examples rather than reading the PowerPoints too. So if you missed any part of that, you want a better overview. This is lecture 1, by the way. So, and I covered all of these things actually. Covered the .m file. I'm just trying to make sure I didn't miss anything out of here. Things to note that we looked at was that minus sign. We saw that. Very similar to C format as the interface. We had the .m file that we looked at as well. So we created some students. Remember the driver program. And we used this applying the methods with the receiver with the message. So we sent students, or what did we send? We sent iOS student a print command. And we sent it a set grades, set get grade. I think I created a get grades and I put it inside of a printf or an NSLog as well. This here is the built-in messages for alloc, init, and release. If you're doing things the GNU step way, you'll have to use an auto release pool. I'm getting away without using it now with Xcode, which is why I'm not really going to cover it. But if you look at this example, here's the syntax for it. You make the pool, you add everything to the pool, then you drain the pool. There's a pool drain, which is actually kind of interesting because pool is the name of the reference variable for auto release pool. So you fill up a pool of objects and you drain the pool of objects. Kind of like going swimming. So we have the word release and retain. Release releases the memory, retain keeps it. So in C++, the old C++, well, I shouldn't say the old. The old Objective-C worked just like C++, except for it had more control. With C++, you have new and delete. It's new, and then it's deleted. If it's not deleted, it's still there. It automatically retained itself. In Objective-C, the old versions of it, you had the init, the release, and the draining of the pool, but you had the retain and the release that worked with that. Retain kept it in memory. Release took it out of memory. So you could leave, let's say, a method call, allocate something inside of the method, leave the method call, and retain it by using the keyword retain on the object, which meant don't get rid of it. Keep it in memory because I'm going to go back to there and I want to use it again in the future. So you might say you had more control over it for that case. So you'll have to release it to get rid of it, which is equivalent to the delete. So the new is the alloc. And then the initializer is the init we saw, initializer. This is basically today is going to be an overview of all these concepts. Tomorrow we're just going to build some projects. Just look at how the concepts again, and I'm going to go over them again, but in the context of a project that we're building. We might even get to it today. I'm going to build a temperature control program that takes Fahrenheit and changes it to Celsius and Celsius to Fahrenheit back and forth. Then it'll be on iOS actually, so we'll take a look at that. But long story short, the concepts need some time and some iteration to sort of sink in. Otherwise, what ends up happening is, you can't read a book and learn how to program. You actually have to have some hands-on experience with it. Otherwise, it's really hard to do it. So, alloc is equivalent to the new, as I mentioned before, and it should be applied to an instances before they're used. It's kind of like a constructor, initialization. Do you have to init? No. If you don't init, it doesn't work. If you don't have an initializer, just run init, just like this. That's the default initializer, and that's the default one of NSObject, which is the super object. No garbage collector on the iPhone. We should release all of the instances memory. That's old. We have garbage collector now. We don't have to release anything. So that's old. And the new version of Xcode actually only works, I've discovered, actually at the lunch break. I tried on another computer, and it doesn't work unless you have 10.8. It won't work on that one either. So even if you have Mountain Lion or Lion, you have to have Mountain Lion and the current version of it in order to get the currently supported Xcode. If you have an older version, just leave it alone and let it work. So some of you may be working with an older version. If you downloaded it from an ISO file or something that was inside of a virtual machine, then leave it alone. Just work with the older version. Doesn't matter what version of Xcode or what version of Objective-C that you work with for this class. If you got it working, use it. So we know how to compile anyway. So I'm going to stop at this point because we're not going to look at data structures yet in Objective-C. So I'm going to pause again. Instead, look at something a little bit more fun. So now what I want to do is show you iOS, and I want to show you devices and little more fun things about more about Xcode. So I'm going to get rid of this other project that I have here. Let's just get rid of it. So what I'm going to show you here, I'm going to clean this up a little bit too. So clean my memory off here. Let's see. Alright, we're all fresh and new. So now what I'm going to do is demonstrate to you how to create an iOS application versus an iPhone app, versus a Mac app one, so you can kind of see what it's looking at. You cannot do this at all on a Unix system or a GNU, using GNU setup. This doesn't work. This is the part you're not going to get. If you can get a VirtualBox set up and you can get the Mac OS loaded on that, then you could possibly do this on a VirtualBox system. Alright, so we know we have these two categories here. We have iOS and we have Mac OS X. I showed you the command line interface. Later on in the course, we'll be looking at the Coca application. Coca application is nothing more than a Windows application. If I load one right now, I'll just show you what it looks like. Test. Not going to use core data. Create a document. It's not going to be a document based. No Apple Store content category. I'm just going to go next. And I'm going to go create. Apple actually opened up the base. Apple, which is bound to happen, was now the base operating system. You can download apps from the App Store just like you do in Windows RT, where you go to the Windows Store and you can download Windows apps for your Windows system. Do the same thing on an Apple now, actually, but not the Windows. You download from the Apple Store. So previously to the last version of the update, we had iOS only through the App Store. Now we have Mac applications to the App Store because they're converting everything to the App Store, which is great. So if I run this sucker, I'm going to see that I've got build successful. If I lower this window a little bit, I have nothing more than a blank window. So I can create really nice looking Windows apps, windowed OS X runs on my computer, not on an iOS device, apps that are compatible with my apps that run on my iOS device, which is really cool, actually. So what do you do with that? You have more fun. You can convert your iPad apps. In fact, a lot of manufacturers now have just one app. It works on an iPad, it works on a Mac computer, it works like on an iPhone. It's just one universal app, and I'm going to show you that in a few minutes. So that's what it looks like. That's a Coca app. And a Coca app doesn't do anything. It just opens up a window. I can drag and drop stuff on the window. If I click on this thing called main XIB, I have a window. And in the window, I can drag and drop items. And I can put stuff in there. And I can show you, well, I'll show you with an iOS app how that works. So I'm going to close this one down. And I just hit this stop button to stop it because it was still running, actually. And now I'm going to come back up here and let's just create another one. So I'm going to create another application here. But instead of going the OS X route, I'm going to click up here to iOS. If I click on the main iOS, I get everything. If I click on the sub pieces of it, I get sub parts of the main. So if you want to see it all, click on iOS. I'm going to click on the application part of the iOS. So we're going to create an application. So I can create a OpenGL game as an example, and let me click on that one actually, because this one I haven't seen yet, so this is kind of fun. I mean, I've seen the older version of it. I want to see what they changed. So OpenGL is also capable as a feature of OS development, so just like it is with C++. So I'm going to go and I'm going to do OpenGL game, and I'm just going to look at the template right now. Those are the templates that I just clicked on that give us a project of a type that includes the proper libraries and the proper setup. We'll be using some blank templates, and then we're going to excel, and we're going to go through the different types of templates as we go through the course. So I'm going to call this OpenGL game. And I'm going to click on Universal. So you see where it says iPad and iPhone. One of the things you get with iOS that you don't get with Android, you got to pick. I want to do it on a tablet. I want to do it on this device. I want to do it on that device. And the devices are made outside of the API. So the developers of like Samsung, Nokia, and all these device developers have to come up with API support for Android developments through the Android system. Because Apple controls the iPads and the iPhones and everything, they can just have one package, one product. And if I select Universal, I get one application. Reformats for the iPad, reformats for the iPhone. It's one app, works on everything. So I don't have to like make 5 different versions of the same app. I just make one, works on everything. So if I select Universal, I'm going to make one for both, which means I'm going to have 2 user interfaces, and I can use the same source code for it. So I'm going to go ahead and click on Next. I'm just putting this on my desktop, so I'm going to click on Create. And now I get this Universal. And you can see on the top here, it's indexing, it's processing. You do have to give it a few minutes for it to actually create itself. I have an 8 GB, plus I'm also running recording software. So this is actually slow, believe it or not. Looks pretty fast though compared to Android. So if I come over here and I look over here, I've got main iPhone storyboard. Looks like that. And then I've got main iPad storyboard. Looks like that. What am I getting here? I'm getting this window that gives me a kind of a canvas to play with. If I run it as an example, I don't have anything on here, but if I run this thing and I run it on, let's put it on the iPhone 3.5 Retina as an example. I'm going to get a little screen that's going to come up in a few minutes now. And this is my simulator, or my emulator, that's going to run my OpenGL application. You see there's nothing on here but a bunch of boxes. Let me make this a little bit bigger. Now prior to this, we had the little window that looked like the emulator, older versions of it. In fact, it's the same template project, which is actually kind of interesting. Looked like a little phone, and now we have something that's a little stripped down. Not as much graphics. The simulator looks, and this is what you get with the OpenGL project. This is an iPhone simulated kind of version of this app. Looks pretty generic in terms of the older simulators. When you load your simulator, if you have an older version of Xcode, it's going to look like an iPhone. In fact, I can probably get that by downgrading. I already installed. If I go into Properties, oops, not for the simulator, for Xcode, you go into Properties, preferences, excuse me, into downloads. You can download, and I've downloaded the 5.1 and the older simulators. So I can change it. This is the current iOS 7 simulators, which is going to give me that kind of a look. So the other thing that you can do with, I think I have it with me, if you have the device, which I do, I have an iPad mini, and I have a cable for it. The other thing people like to do, and this gives you a much more realistic view, is what does it actually look like? So what you do is you take your device, plug it into the computer, and let's stop this here. You can press the button here and stop it. And you can kind of see some icons in here. We don't need the picture library up. I have a clock. There's an app I was loading earlier, actually. Well, let's just stop that one. I can load, this is stuff that was already on the simulator, so I can stop the simulator. So let's say I want to, now I can say, well, let's say I want to run this guy on my device. So I can kind of come up here and say iOS device, which is the device I just plugged in. And if I come in here, and let's change the window to the, let's see, real quick. I opened up the organizer window. What I've done is I've registered restore using iTunes. Now this has got a 6.1 on my device. I haven't upgraded it, obviously, because I haven't plugged my device in today. My Xcode is actually more up to date than my device is. But we're going to leave it alone. I'm not going to restore anything on it or do anything with it. Instead, what I'm looking at is I have my iPad here, and I have an identifier, and I have it registered, and I have this little green little button here that says that I have a provisioning file. So you go to developer.apple.com. This is what I was saying earlier today. If you have a Mac computer and you have a Mac device, like an iPhone or an iPad or something, I see you guys have MacBooks. Maybe if you have, I can set you up with a developer account so you can do what I'm doing. Doesn't work through Ubuntu or anything, or GNU Step. It won't work through your ThinkPad either. You actually have to have the MacBook, because you need to go through Keystore and get a signature, get a certificate from the Mac system, from the hardware. Registers with developer, allows me to run my apps on my devices. So I don't have to put it in the App Store. If you're going to put something in the App Store, you also need an Apple computer as well. You can't do it through some third-party tool that's simulating this, or some emulator software. It's not going to work. So long story short, it's another reason why you want to get a MacBook. And you want to load up on devices so you can run your beautiful apps on the device. And so what I'm going to do now is just run it on the device. So I've plugged it in, and I can see I've got a provisioning file set up, and I'm all ready to go. When you plug yours in, if you actually have a MacBook, you're not going to see this unless you've got a provisioning device. So what we do is there's a 5-step process, or a 4 or 5-step process. We exchange some information. I go online. I add you to the ITU educational account. It's free. If you do it on your own, it's $99. If anyone's interested in doing this, come see me later on. Let me know, and I'll tell you what I need. First thing I'm going to need is your device ID. So, and then serial number of your device. So you'll have to have your device, you'll have to have your Apple computer, and you'll have to have Xcode installed correctly. And the current version of Xcode, by the way, in order for this to work. So, all right. So I've got my iOS device, and now if I say this Xcode can't run using the selected device, no provisioning device files. Okay, I have to fix my provisioning. So actually, let me try something else actually. Let me download an old project. This, prior to my update today, this actually worked. I've been using this iPad here for years. So let's go into source code examples. Let's see. I want to do temperature control. Actually, let's go back here. And go into PowerPoint lectures. Yep, hold on. Let me find one. I think that should work. Let's just use a digital clock again. That's the tutorial for it. Hold on. I'm going to download the digital clock solution. I used this one earlier. I know this one is of a previous API that should work. Let's see. Skip it. I don't want to upgrade it. Here we go. There's Barbara Hicker's iPad. So if I run it, it will load the digital clock display. Let's see. On the iPad, which, there it is right here. I'll make it a little bit bigger. It says an iPhone, and I loaded it on the iPad. So you can see you can probably, from a distance, you can probably see the green on the background maybe. But this is the same thing. This is the clock project that runs. So if I close the project and I look at it, I have the icon here. I can run it again. Actually, it's installed on the device without going through the iTunes store, which is how a lot of people, developers, like to test things. Because you don't want to like put it into the store just to have people install it to test it. So there's no, oops, it automatically adjusted. There's no replacement for actual device testing. If you're going to get into this, you're going to have one of the devices of all the different kinds, and you're going to test it on all the different devices. The emulators help you test without having to actually own the device. But what works on the emulator may or may not necessarily will look the same and work the same on your device. In fact, this one is kind of an interesting, this stopwatch I bet is going to work now. Yeah, this one works. The stopwatch functionality used to work. I tried it earlier at the lunch break, and I noticed it wasn't working on the device. But I can see here I've got, it says 10, 11, if I stop it, 12, and it stopped. So the stopwatch does work on the device. We'll see in a few minutes here if I stop this. Run it on the emulator. Let's see what happens here. Run it on the emulator. Where's my emulator? Oops, it's still running it. I'm sorry. It's still running it over here. Okay, stop it. Change the device. I want to load this on an iPhone, and I want to put it on 6.0. And now I'm going to load it here on my, look at that emulator. So I like the old emulators better. I like the way that the old ones work better. It just looks like an iPhone, you know? And then I can start to counter. So I got 1, 2, 3, and I can stop it. And it works. So this was built in 6.0, which is why I selected 6.0. It works just fine on my 6.0 operating system on my iOS. Works just fine. I'll show you something else in a few minutes I just discovered, and inevitably we're going to have this problem throughout the course. I'm going to double click on this project, and now I'm going to select, well, let me try this again here. Actually, let me close the project because it's already been updated. I'm going to unzip it again. Double click on it, load it back up. And now I'm going to say upgrade it to 7. And now my buttons went away. So now if I load it, well, see, actually this is interesting. It's set for 6.0. Let's see what happens if I get the 6.0 emulator. No, simulator failed to install the application. Not going to go backward compatible on me. So instead I'm going to select a different. I'm going to go back up to iPhone, and what am I going to have to put it on? iPhone Retina 3.5 7.0, because I upgraded it to the 7.0. So now I'm going to run it, and I see the 7.0 simulator. So your simulators are going to look different, your interface is going to look different, and now I'm going to notice that my functionality is not going to work. Let's see if it works actually. I shouldn't do. It worked. I don't know why it wasn't working earlier. It wasn't working earlier, but now it's working. So I got 5, 6, 7, 8, stop. So now it's working. Don't know why it wasn't working a few minutes ago. We're going to build this, actually. We have another temperature controller that we're going to build because the only way to learn programming is to really do it. I'm actually not going to use 7 because I'm not too familiar with it, and I don't like the way the simulator looks. I don't like the fact that I don't see my buttons anymore. It's because I have a 6.0 project that I'm running in a 7, and quite frankly, until this morning, I haven't seen 7. This is my first look at it, so I got to get more familiar with it before I'm going to teach with it. So we're going to go down to 6.1 or 6.0 for this class. So don't be concerned if you don't have 7, it doesn't matter. So, but long story short, that's what the project looks like. The interesting thing is it's kind of create an old project using the newer project type, which is actually going to be kind of interesting. Let me actually kind of see, and I might even end up having to explore on my own. Create a new project. Is it going to give me that? Well, I got a single view application here. Let's just see real quick. I'm not going to use the game this time. Instead, I'm going to go testing. And I'm just going to create an iPhone one just to narrow down everything. And go next. And put it on my desktop. I believe by default, and I'm getting the newer project. And one thing to point out, and the interesting reason why I sort of did this, was to see if the project type was still going to follow model view controller, and it does. So one of the things I'm going to talk about, probably not till tomorrow, is this model view controller, where we have the app delegate, which is the data. So model view controller, the M in model, MVC, is a design pattern that came back from the original object-oriented concept. Objective-C follows it, iOS development follows it, Android sort of follows it. The newer API, the newer development tools, follow it more than the older ones did. So they're moving in that direction. The M, or the model, stands for data. It's the data model. They call it model instead of data. That's app delegate. It's doing that. The view is the view. This is the storyboard view, the view controller. The controller is the view controller. So we have 3 different parts of the application. We developed the 3 parts separately. We have the data storage, we have the view, and then we have the controller for the view. Another reason why you want an app book, you can't, or MacBook, excuse me, you can't do model view controller on a Linux system either. You got to use the tools for it. But long story short, if you focus on the 3 different areas of it, you build a better design pattern, better, more stable application that you're creating. So in this particular case, what I want to try and do is see if I can do it on an iPhone non-Retina. Let's see, iPad, iPhone. No, I'm not getting the same options. So if I click on the project and I go into the settings in the beginning here, I see that my deployment target is 7.0. And I don't see any option to change it, which is kind of interesting. So one of the things that I'm going to need to do is figure out how to backtrack this down so we can look at the previous versions, if we can. Otherwise, maybe we'll just get familiar with 7. iOS 7 in this class. So you'll see iOS 7 before you see it on your devices, probably. Yes? Oh, okay. So now what I want to do is kind of take you through a sample project, and I'm going to do this using the iOS 7 because I'm going to force myself to kind of get used to it. So if you're following along, we're going to create a Hello World actually application. So what does Hello World do? It just prints out something to the screen. So what I'm going to try and do is see what the differences are. So I'm going to, the last project I created was using a storyboard. I don't want to use a storyboard. So I'm not use a storyboard. So create a new Xcode project. And I'm going to go under the iOS and we're going to create application. We're going to use a single view application. And let me click on next. And I don't have an option not to use a storyboard. Interesting. I thought maybe there would be an option here, but there isn't. They took away my storyboard. So this is a project type of a 7.0, so we'll do it with the storyboard. It's no big deal. And I'm going to call this one Hello World for iPhone. Because I'm not going to use the universal, I'm going to use the iPhone. So, actually, I have an iPad here. I can run it. I can't run it on this iPad because it's 7. I have to update this one to 7. So I'll stick it on iPhone. All right. Tonight maybe I'll try and update my iPad. So I can run it in the emulator. No big deal. We don't have any of the other options that we used to have in the previous versions. So I'm just going to press Create. We don't actually have to do the source. We don't have to create the repository either. So I'm not going to do the Git. So I remove the Git, the checkbox here, because this is just a sample. I'm going to throw it away when I'm done with it. So now what I want to do is kind of show you how to create the interface, how to do the Hello World, actually build something rather than just using the template. So we have a file in here that's called main.storyboard. As I mentioned before, it gives us our view. We can click and move this file around. It's going to show up in the middle, and it showed up when I clicked on main. If I don't see it, I can click on these parts over here to make sure that I can see it. And it's going to be this, we got the source code view. It gives us our tuxedo. I call this a tuxedo icon. It gives us our controller that goes along with our view. So right now I'm going to put it back on the main single line and show you how this right hand side looks. So in the view we have a scale to fill. We'll just leave that one alone, and the background color is white. I'm going to change this one because all my programs have green background to them. So I'm going to change the background color here, and I'm going to leave the default alone in terms of the tint and all the other properties, and we'll go through some of the stuff. The auto resize of subviews, we'll leave that alone as well. On the bottom, I have these little buttons that you click. The buttons that you click take you to different items that are in. If you click on this one here, I see view controller. Well, I want to look at a label. So I'm going to type in label, and I typed it in on the bottom. So label says there's a label. There's a variety, size, amounts, and static text. So I'm going to drag the label. Used to call UI label. They just called it label now. So I'm going to put the label on here. I'm going to double click on the label. I'm going to write here Hello World. And then I'm going to make the label a little bit bigger. And I'm going to come over here, and if I click on the background, I see the view for the background. If I click on the label, I get the properties for the label. The properties are coming out of this thing they used to call the attribute inspector. It's still in here. It's still called the attribute inspector. That's nice. We have identity inspector for whoever owns, and it's called a UI label. So it said label down here, but it's really a UI label. I know that because in the old days it used to say UI label down here. So it's kind of funny. Why they took it out, I don't know. We have information about the class object, the Coca interface it comes from. This is from Coca Touch. It's on the storyboard. We don't really need to do anything with that. Actually, we can kind of see from here that it's coming from iOS 7 and later. So we can open in default 5, which is what we're going to put it in. So anyway, if I go back, we can play around with that. The text looks like plain text. We can change it to attribute text. I can change the font and the color of the text. So I'm going to change the color of the text. I'm going to make the text red. So I'm clicking on the little wheel over here. And, oops, there we go. I'm going to check and make the text red. And probably should make it blue or bold or something. So I'm going to come in here and click on the system is the font that I'm using. I can change the size to, like, let's say, actually I'm going to use the buttons here, make the size bigger so it fills up the whole screen. That looks pretty good. Press done on it. So now I've kind of changed it a little bit. If I wanted to, in the old days, and I can still do it up here, I can change the text in the attribute window. I just added an asterisk on here. I had to make it a little bit bigger so I could see it. But this is really just plug and drag and drop and put items on here. So that's a label. If I wanted to put a button on here, I can go button. If I have button, I can go, well, what kind of button do I want? I have a button. I have a button bar item. Put things on a button bar. I can have a fixed space button. I just want a button. So I'm going to put a button out here. And, oops, I got a button item. I selected the button item instead. I don't like the item. I just click on it. And I can press delete. Whoops, I deleted the wrong thing. I can just undo the delete the view. So I can just leave the button item alone. Let me click on this one here. Is this the one I wanted? So now I got a button. And I can see, actually this is interesting, the button doesn't show up in my view. So I'm going to take a look at the button properties. And it's just a button. So type, let's do custom. We used to be able to put an image on the button. Here's an image. We can put an image on the button. Do I have any images in here? Don't have any images. So let's download an image, and I'll show you how to put an image on a button. Actually, might make it more fun here. So I'm going to go to the internet, download a PNG image, drag it into the project, and put it on the button. So you can sort of see how this works. So I'm just going to go to Google. Attendance? No. Oh, hello. Did you have something?
This is your first lecture continuing, right?
Yes.
Okay.
This is the first day of Objective-C programming.
Okay. So just whenever lecture, you are doing recording, right?
I'm sorry. Yes, I am recording. Are you from media team?
Yeah.
Okay, good. Yeah, I recorded on here. At the end of the day,
Yeah.
come in and give me a flashcard. I copy on there for you.
Okay. Thank you.
Okay. So let's just do .png. Let's go some images. Oh, I don't know. Probably that wasn't a good thing to search on. I probably should find some images here. Toys. I don't know. Toys R Us. No, let's see. Images. Ah, here's some. Now, I like this guy here. So I'm going to steal this guy. I'm going to save the image as bluetoy.png. So save it. So I saved this little image, and I have a bluetoy.png here. I'm just going to drag it, put it in my project. And I'm going to copy it into the destination folder, because I don't want to link directly to the desktop, because I'm going to remove it later. Actually, I'm going to remove the whole thing later anyway, so it doesn't really matter. So now in here I have a toy image here. If I click on the toy image, I see the toy image. So I can still go back to my storyboard. I'm going to click on this button. And I'm going to come in here, it says image. I'm going to click on the little arrow. I'm going to select my toy image. So I put those, oops, hello. This image is a button. So I'm going to take the text off of the button. The button has some text on it, but remove the text. So the button's kind of big. I maybe make the button a little bit smaller here. All right. Probably could do a little bit better with the scaling. So maybe when we press the button, something's going to happen. So I got a label, and I got a button. So now I'm going to say, well, how do I make something work out of this? This is why I take Objective-C programming. See, this is the fun part. You build up your interface, and if I run it right now, I should get like an iPhone emulator. I'm going to get that 7.0 thing that shows up. Okay, I'll just deal with it. So I wonder why, it's interesting. I wonder why they, there's my hello world. I got a button. I press the button. It looks like a button click happened. Normally I touch the button. If I put this on here, just touch the button, but I got to upload this to 7.0 before it works. But all right, so let's change the text when we press the button. How's that sound? That sounds pretty good. So I'm gonna, and if I exit out of here, how do we exit? Well, I don't have an exit for this here. So if I put a button here that closed my app, it would take me back to the iOS screen. Otherwise, I'm just going to close it. I have 8 gigs on this computer, so I don't necessarily have to worry about leaving the emulator up. If you're running on an emulator device where you're running through a virtual box, leave the emulator up and just keep running it over. You can just stop it from here. Leave the emulator up. You don't want to keep loading it over and over again. It's too slow. It's going to run slower. So anyway, I'm going to close it. Instead now, I don't like the way that this guy looks here. I'm going to leave it alone, actually. So let me just see if I want to change anything else. Nah, I'm pretty good. I'm pretty good with my other properties. I'm going to leave this guy alone. All right, so now what I'm going to do is I'm going to get rid of the side piece. I got rid of the side piece by clicking on this little button over here with the side little arrow. So I'm going to get rid of it. I'm going to click on this little tuxedo icon. So this little button here gives us the standard editor. The standard editor is just a screen. This guy over here is on because I got this guy selected, and I don't have my bottom guy selected. I just left him off. So the blue tells me I have the blue side. That's all. So I have 3 different screens. Once you get familiar with the terminology and look, it makes it just becomes second nature. It's actually kind of intuitive. So if I click on the icon over here, this little thing here that looks like a tuxedo, I get the code that works with this view. And I can make this screen a little bit smaller so I can sort of see the view in here at the same time. So that looks pretty good. So if I can click over here and I can click over here and I'm good. So over here I've got a .m file. I really want the .h file. Because what I'm going to do is kind of drag and drop and create definitions. And what I'm going to do is I'm going to drag and drop these components, and I'm going to put them in between the @ interface and the @ end. First thing I'm going to do is make a property out of this the label. So I'm going to press down the control on my keyboard, and I'm going to drag it over here, and I see this lovely little arrow that comes up. And then I'm going to release, and I see I have an outlet. So I've got a UI label, and I'm going to call this one the label. So the label is going to be weak, which means garbage collected if it's no longer being used. If I switch to another screen, if I do something with it, I'm no longer using the label, it's weak. Just get rid of it. If it's strong, it means restore it, retain it, keep it forever. Don't ever get rid of it. So I'm going to press on connect. Now you see I have this little button here. If I put my mouse over the button, I see this little Hello World label get highlighted. So now I see a thing called a property. Now in the older version of the iOS, and I'm working with a new version of iOS, so you got to bear with me here. You used to do a synthesize over here, and it doesn't do a synthesize. And I've noticed actually, and this was actually of the 6.0 version, I have an @ interface and an @ end over here in my .m file. For those of you who missed it, I switched up here. There's 2 files that work. Remember that stuff we did this morning with person and student? Same concept. This is called a view controller object. The view controller object controls my view. So this is why we want to learn about .h and .m and about objects. Instead of creating a person and a command line prompt and just nslog some stuff, print out some stuff, we can use the object to control the view. And it's a view controller object, and we can have more fun with this. So I'm actually going to remove this. I could keep it. If I wanted to do some stuff, I can keep it. I'm just going to remove it right now, though. And so I have a view did load method, and I had a did receive warning, memory warning. I'm not going to get a memory warning. I'm just loading one item. But if I was running low on memory, I could get a warning, and if so, I could release some objects if I wanted to. I'm just going to leave it alone. Instead, at the top here, I'm going to type in @synthesize, and I'm going to put the property in here, the label. And I'm going to put a semicolon at the end of that line. So I'm introducing something brand new to you. It's an @property and a synthesize. And you're wondering, why in the world is she showing me this? Well, remember the setters and the getters and the data initialization and everything that we just looked at with person? This does it for you automatically. It's a shortcut mechanism. The property and synthesize creates the set label, get label, and the whatever this thing is called the UI label. I could, if I wanted to, let me go back to the .h for a second here. I could do it the manual way and say NSString. Let's just make an NSString, because then I can just use the NSString. NSString some text. And then I can put the closing bracket in here and get rid of that error message. I can do it this way as well. I just created a variable called NSString. And if that's the case, I don't do any property synthesize stuff with this, just a string. So I can use the string, and I can say over here, if I wanted to, that the NSString was equal to something. And I can take the NSString and copy it to the label if I want to. We'll just leave it alone. We'll just put it in there. I don't know how I'm going to do this yet. So instead, I'm going to go back to the .h and sort of finish. I have this other button here. So the label, and just take this with a grain of salt right now. Get one of those books from the website. You know, learn everything you want to know about properties. But just imagine this is the same thing as this. Except for with this, I have to create a bunch of methods. The methods are going to be set some string, get some string, do a bunch of stuff with some string. This does it for me automatically. I have an item, instead of calling it a string, this is actually a label. Here's the part here. I could do this if I wanted to. Copy it, put it under here, and say that this is going to be paste. I have to call it something else. It's going to complain because it's the same name. I'll call it T-label or something of that nature. The error message went away. Now I got this little bubble here. It says, hey, we're not connected to anything. Well, let's go backwards then. So if I put it here, instead of doing a property and synthesize, which is what, you know, is probably the easier way, I can connect it backwards. I can click on this guy, press the control button down. Oops, actually don't even have to do that. Just drag it this way or drag it this way. Press the control button down. Oops, I'm on the button. I want to do the label. Let's drag it to the right spot. Oops, take the breakpoint off. I can drag it to the label this way, or I can drag it the opposite way. I can come to the label, control drag it back to the object. So it depends on whether you think left to right or right to left, I guess. When I see the buttons, I like to do it this way. Oops, let's take this off. I like to take this button here and drag it up this way. Now I see I have a solid thing. That's a breakpoint, by the way. I accidentally kept clicking on that. I'm going to unclick it so it's not highlighted. I should probably remove the breakpoint, but it's okay. We don't need it. What I've done here is I've connected, so I can press here and I can press here, and I've got two items that are connected to the same. Why can't I have as many connections as I want? So basically I have two variables, one I created manually, the other one I created with property and synthesize, that both work with the same GUI component, the label. Take it with a grain of salt. It'll all make sense about the 5th or 6th time you do this. So now I want to connect the button. I've left out the button. So I'm going to right mouse click on the button. I could take the button and I can press the control button down here actually, and I can give it an outlet property, but I want the action. I want the click action to be. So I'm going to just say this is the outlet. So this is the button outlet. And it's going to be a UI button. It's the name of the object. I can make it an ID if I want. The type can be ID, actually, be generic. So I'll leave it on and we'll leave it weak, the same as before. If I do this, now I have another property. But that's not really what I want. Instead, I want to turn it into an action. So we have IB, which IB stands for Interface Builder. This was called the old Interface Builder. It turned into the storyboard. So it's funny, and I was actually kind of seeing if they changed they didn't change it. It still says Interface Builder Outlet. Well, we don't really want an outlet. An outlet's like I/O, outlet. Print something to the screen, get something from the user, kind of like a tunnel. What I want is an action. So I'm going to click on here, right mouse click, and this little button action screen is going to come up. And the action that I'm interested in is the touchdown event, one of these touchdown events. So I'm going to drag the little button here. It says, you can't see it, but it says, actually you can see it better on the screen. It says touchdown. What do we got? We got touchdown, touch up inside, touch drag, touch up outside, all the different things you could possibly do with your finger on there. Touch it this way, touch it that way, touch and drag it. And we'll see, we'll play, there's a cool little game. It's uses like a jigsaw puzzle. You remember the old jigsaw puzzles? You know, you get 1,000 pieces. We're not going to create 1,000 pieces, we'll create 5 pieces. You drag the little things over and you put them together and you position them on the screen. You build a picture out of it. We'll make one of those in this class. You'll find out how easy it is. It uses one of these mouse motions or touch motions. It's a gesture, actually, and it's going to be a move gesture, touch gesture that we'll work with. So primarily what you're looking at when you start working with this interface are the gestures and the touch controls. So let's just use a touch down, and we're going to drag the touch down over here, and I'm going to call this one the button. Because I called the other one the label, I'm just going to be the button touch. Let's just do the button touch, which is the touchdown control. And you see over here where it now says the ID type is ID. I can change it to UI button, or I can leave it on ID. You guys know what ID is because I told you that this morning. The ID is the generic. Well, if I know it's a button, I'm going to call it a button. Use it as a button. The event is the touchdown. If I don't like what I selected here and I decided, well, I want to select another one, then I can click on here and select any of the other options that I have here. Let's just do this touchdown event. So I'm going to press connect, and now I have this, and I can actually close this screen now. Now when I hover it over, I see, well, that's the button, that's the label, that's got the label here. So I got it. Looks pretty good to me. So then now I can flip over here to the .m, and in the old days they used to create, remember we had the function prototype, that's a method prototype, not function, it's called a method. That's the method prototype, and I'm looking at the method prototype, and most people are going, okay, well how does that differ than what we just looked at this morning? We had void and we have integer. Well, this data type is an IV action. The data type's different. It's not void or integer. Now it's IV action. The name of the method is still the name of the method. And this one is called the button method, or the button touch. We have a colon in here because it's taking something. It's taking a parameter. What's it taking in? It's a UI button asterisk. It's a pointer to the asterisk, which is the sender. It's taking an event. The event is the touch event that we specified. So when we touch it, touch down actually for that matter, sender comes in, UI button is the data type that sent this message. This will automatically receive it. So we can put something in there that does something when the button is pressed. What are we going to do? We're going to change hello world to something else. I got pressed or something. Or change a label to something by setting the text of the label to something. Because we have a set text and we have a get text automatically because we have this label here that we property and synthesized. So I'm going to switch over to the .m file, and I'm going to see, lo and behold, on the bottom I have the template given for me for the implementation. So the implementation can actually speak with, because I synthesized this object over here, the label. So in here I can put an opening and a closing bracket, and I can put a message in here to send to the label. So the label comes up. And I can say set text, or set value, let's see, set value. Can I do a set text? Set text. What am I going to set the text to? Well, let's set it to the @ directive, and I said button was pressed. Button, whoops, I had to put some quotes in here. Button was pressed. You're wondering, what in the world did she just do there? Same thing we did this morning with the show, with the person object, and with the student. We had a little command line thing. We ran the method. What method did we run earlier? We said person, what was it? Well, I think it was called my person or something. And we ran show in here. And show printed out the text. So in here I'm going to say the label, which is this label up here. Because I property and synthesized it, I have a set text and a get text. I'm going to set the text to something. If I have an input box, an input field, I could get the text. Get the text and then set the text. So the classic hello world program that you write, hello text box, enter your name. Enter your name. You're pressing OK and it says, hello, Barbara. Because it got the text from the text box, text field. Took it and it set the text of the label to the text that it got, and just like a little button that you press. This one's a little different. The button press is going to say it's going to change the label. This is kind of big, so I'm wondering if it's actually going to show. So I'm going to make this a little bit smaller. I'm going to say whippy, whippy. That's going to fit because this guy here is going to say whippy on the label. So let's see. This is the opening and closing bracket, just to be clear here. And I put a string in here. And the string is going to be sent to the method setText, which is given for us automatically. And I'm sending the message to the label. The label's got it because the property synthesized it. So if I run it, let's see what happens. I got a build successful. I come up here. The big part is, does the button work? Let's see if the button works or not. Here's the button. I press the button. It says whippy. So if I press it again, it doesn't do anything. So I can set a counter, say, and flip it, so whippy is going to equal to 0. So let's do something different with this. So I'm going to close this for a second, because I want it to be a little bit more functional, and plus we're learning Objective-C today, so we're going to play with some variables. So let's play with some variables. I'm going to go back up here. I'm going to switch it over to the .h file. And here I'm going to put it in here an integer count. Or how about selector? Select integer select me. I can figure out how to. Actually, let's do counter. I can remember that one better. Counter. It doesn't really matter what you make it. Okay. So I got integer counter, and it's going to be 0 automatically. We know it's going to be 0, but when we press the button, we're going to change counter, and we're going to make it 1. And then when we press it again, we're going to make it 0. So if it's 0, say whippy. If it's not 0, say hello world. And then switch back to 0. So the next time we click it, it's going to say whippy, right? So, or something like that. So I put the counter in here. If I wanted to initialize it, I don't have to initialize it because we know it's already initialized to 0 because we're learning Objective-C and we know that. If we don't want to rely upon that, a lot of people would put it in the view_did_load. The view_did_load is one of those methods that runs automatically when the view loads. I'm not going to put it in the view_did_load because I know it's going to initialize to 0. I have no doubt in that. However, some people want to do it. So, whatever. We'll just put it in. Well, okay, if you're going to do that, you can put it in here. And if you're going to do that, you're going to go counter is equal to 0. So now I know for sure I got the counter is equal to 0. This runs on run the super view_did_load. What's the super object? It's the native object. It's not NS object. If you notice here, we haven't inherited. We've inherited from UI view controller. This guy's not an NS object. He's a view controller. And you can look on the bottom here. It used to say it. If I click on, well, it's not going to show it. But this is called a view. Actually, sometimes if you click that, here it is, view controller. You can kind of see what this guy's called. He's a view controller. Well, this is the view controller. He's the view. We're in the view controller object. So we're a special kind of view controller. We're the enhanced version that has the button and the label on it. So in here, in the view_did_load, all we're doing here, in fact, we can get rid of this. You don't need to worry about that comment. All we're doing here is loading the super view_did_load, and then we're setting the counter is equal to 0. It's kind of like main. You want to think of it. It's kind of like the start of the program, but we're event-driven. We're not running line by line. If we wanted to run line by line and turn this program into a console application and just print some stuff to the screen, we put it all in the view_did_load. We don't actually need this method here. I can delete it, no problem. I'm not going to. I'm just going to leave it in here because I'm not doing anything with it. Is if we received any memory warnings. So we have a view_did_unload, view_did_pause or suspend. Oh, we have all these different life cycle methods in here that we can work with, but let's not worry about it. So in here, this is going to look extremely similar because I'm going to write some C code. This part you already know. If you've written any Java programs, any C programs, any C++ programs, you know this part. So I'm going to say if, and this is the beautiful part, is that Objective-C syntax is very C-like. In fact, it uses native C. I'm going to write this in C. There's no way to do this in Objective-C. It's borrowed from C. Works well in C. Why not do it in C? I'm going to do one of these if, else, then kind of things. So if counter equals 0, then, well, we don't have to do it then. And we're going to put some opening and closing brackets. And I misspelled counter, so I'm going to spell counter correctly. So if a counter is equal to 0, then the label text is going to say whippy. Else, let's put a little else in there. I'm just going to do the else variety that has the, just not the else if, just the regular else. And here I'm just going to cut and paste because I'm a terrible typist. And I'm going to put it back. And so if it doesn't equal 0, whoops, I have to change the counter too. So I say copy, paste. Whippy, I'm going to put it back then to, as if nothing ever happened, it's going to say hello world. It doesn't really have to. I can have it say something else if I wanted to. And then I'm going to change the counter, and I'm going to say counter is equal to 0. Is equal to 0. But then I have to increment the counter on the other side, so the counter is going to be equal to 0. Here, I could go counter plus plus. We're going to go counter is equal to 1. It doesn't really matter. I did counter plus plus. How's that? Or counter. Here, we'll just do an on and off. We'll just do counter is equal to 1. Half a dozen and other ways of doing that, but I hope at this point you got the concept. So I'm going to get rid of some spaces here, get rid of that stuff. Make it look pretty. This is causing you problems because you haven't taken a programming course before or it's been a long time. I highly recommend just getting an old C book. Or actually, if you get one of those Objective-C books, you don't have any assigned reading for this course. This is what I call competency-based learning. Each one of you is from a different major, from a different school, different undergraduate experience, different background completely. The objective of this course is to learn Objective-C programming and to get an idea about how to do this. I can't tell you that this is your homework assignment. You have to read chapter 1, read chapter 2, chapter 3. Some of you are going to have to read chapter 1 of one of those books to even understand what we're doing. Some people might have to read chapter 2 or chapter 3 out of a couple of those books. Who knows which book it's going to be. It's going to be whatever book you're going to find helpful. So think of it as competency-based. You want to get competent in writing Objective-C code for iOS, or for OS X. We'll be looking at it for OS X as well. So if this is complicated to you, I'd say you need a basic programming book. I'd say you need Deedle and Deedle, or you need one of those I gave you off of the free list. Those books are great. This hasn't changed in about 50 years. This is C code. I don't know how old C is, but I want to say it's about 50 or plus years old. So this is basic C syntax. That's the same as what you're going to use. Objective-C is built on top of C. So let's see the sucker run. We're going to load her up. Man, I'm going to have to get used to this new simulator. Hello world. Whippy. Hello world. Whippy. Hello world. Whippy. Hello world. Whippy. Alright, well, okay. So that's our first program. Come on. it's not rocket science. Hopefully by the end of this weekend you can do this on your own. That's the goal. It's the baby steps. Imagine, actually it's not too bad. In fact, we can do it next. Is we can have multiple items on here where you press multiple stuff and it does read some stuff from boxes or changes stuff on the screen or does something. So GUI programming is pretty easy. It's finding the images you like, putting the screen together, making it look pretty. Go next door to the digital arts department. I'm terrible. Actually, this isn't too bad, but I'm terrible with UI. UI design, don't ask me advice on that one. I'm better with the mechanics of it. So, although, if you keep it simple, and that's my best advice, it looks better. I've seen some apps out there that look like you took a bunch of stuff and you threw it. It's like a clown in a blender. Throw the clown in the blender and it spit up all over the page, and it just looks like crap. And it's just like, if you just got rid of half of that, simplified it, made it easier, it would be a much better app. So think minimalist. Only put a couple items out there. Don't confuse the user. And then also don't put like light text on a light background or dark text on a dark background. You know, and change it so you make it so you can't read something. You know, as an example, I chose red for this. If I put like green, lighter shade of green on top of the screen, you probably wouldn't be able to see it. Or if you pick a button, it doesn't look like a button. It doesn't look like something you can click on. Half the problem I have with some of these apps is that you don't know you're supposed to touch there. Because the button doesn't look like a button. Or it doesn't look like something you're supposed to touch. You're supposed to do something with. And you go, oh, that's what you're supposed to do with that? So anyway, that's the only advice I have for you in terms of UI design. All right, so now what I'm going to do is find out if we have any questions first. If not, what we're going to do is I'm going to stop this video, we'll take a 5-10 minute break, and then we're going to create a Fahrenheit to Celsius program. And I'll show you where the tutorial is, and then we'll walk through this one and build another app. So what we're going to do for most of this weekend is instead of showing you boring PowerPoint, is I'd like to do what I just did, just show you stuff, and then you can see how it works, and then you can see after you've seen this, because what I'm going to do next is something very similar to this, but it's going to be slightly different. Instead, we're going to do some calculations on some variables, and we'll set some Fahrenheit to Celsius conversion ratios and stuff. It's pretty fun. Long story short, it's the same stuff over and over and over again. Once we create multiple sets of variables, it sinks in after a while. So it will sink in better if you had a development computer to work on. But that's a different story. All right, so let's take like a 10-minute break again. So I think it's about 4:30. I'm hoping the attendance is going to show up soon as well. So. All right, break time.